All right, I'm back. I am on page 264 this time, and we're going to talk about basic limit laws. And so these are really important, but they kind of just make sense, and that's really good. And we don't want to like belabor the point, although we're going to do that on some of these problems. In general, you end up not really thinking about these. There's one part that is really important that I'll try to highlight, but let's see what we can do. So here are the basic limit laws. Assuming that the limit as x approaches c of f of x and the limit as x approaches c of g of x both exist. That is an enormous assumption. Let me highlight that because that's going to be important to us. Assuming they both exist, then you can use these laws. If they don't both exist, you cannot use them. So here we go. I'm just going to say them the way that I usually say them. The limit of the sum is the sum of the limits. So the limit as x approaches c of f of x plus g of x is limit as x approaches c of f of x plus limit as x approaches c of g of x. So the limit of a sum is the sum of the limits. For any number k, any real number k, the limit of a constant multiple times the function is the constant multiple times the limit. So the limit of a constant multiple is a constant multiple times the limit. So that just means you can factor out a number if you need to, which I do kind of frequently, especially with fractions when they're in the way. Next one. Limit of a product is the product of the limits. So the limit as x approaches c of f times g is the limit of f times the limit of g. But remember, this is assuming that both limits exist. And then finally, as long as you're never dividing by 0, you can never do that. So it's going to be a problem. The limit of a quotient is the quotient of the limit. So the limit of f over g is the limit of f over the limit of g. All right, let's do some problems. We're going to do them in a way that you will never do them again. But the first time through, you know, baby steps. Let's see if we can do this. So one way of evaluating this is direct substitution because x cubed is a continuous function, so you should really just like go for it. What I'm going to do is a little weirder. I'm just going to like show some of the limit laws, right? So this one way of thinking about it is the limit as x approaches negative 3 of x times the limit as x approaches negative 3 of x times the limit as x approaches negative 3 of x, which is just going to be negative 27. Negative 3 times negative 3 times negative 3. So negative 27. Another way of thinking about it is, this is a sort of weirder one, but you could think of it as, well, it's actually pretty obvious from what I just wrote. Bring the limit inside, right? So do this and then just cube that, which would be negative 3 cubed, negative 27. No matter how you do it, you're getting negative 27. All right, so for the next one, I'm going to do a slightly different technique because I do not want to write all that out. I'm going to say that this is the limit as v approaches 3 of v cubed minus 2 times the limit as v approaches 3 of v squared plus, these are the weirdest limits, the limit as v approaches 3 of 6, right? Like there's no variable there, so the limit, v can do whatever it wants. 6 is just going to be 6. And that actually comes up a lot, so keep that in mind. The limit of a constant is just the constant, like it's never going to change. So here we would get 27 minus 2 times 9, and then plus 6. So that's 27 minus 18 is 9. 9 plus 6, I think, is 15. I think we're getting 15 there. All right, so I'm just doing each of these in kind of like a sort of weird way. I wouldn't do these really this way, but like the first time that you do the problems, it's good to think about the limit laws. Like here I'm allowed to do, provided both of these limits exist, I can divide this up. As x approaches negative 2 of t minus 4. Should probably make that look more like a parenthesis. And so overall, this would be negative 2 squared plus 4 because it's polynomial in the numerator. So that's going to be 4 plus 4 is 8 over negative 2 minus 4 is negative 6. So negative 4/3. All right. I'm going to try my best, obviously, to get all the numerical calculations right. But if I don't, you know, whatever, just fix them on your notes. Let's go with a different color here. All right. So what can I do? I'm actually just going to do it. So this will equal 3 times 5 times 6. So 90. All right. And then let's see. I just made some gesture on my iPad, like a twisting motion, and it was like no operation to redo. I think I just found an accidental shortcut to redoing things. I don't know what it would be. This one, we can do the limit of a quotient is the quotient of the limits. So let's do that. Just trying to illustrate these in use. Because in practice, you just kind of like try to do the problem, and if it works, it works. And if it doesn't, you're like, oh, I guess that didn't work. So here, I'll do this of x plus 3 over the limit as x approaches -1 of, but these are both polynomials, so we know that they're continuous everywhere. The only issue we could have is the denominator 0? If the denominator is 0, then the limit doesn't exist, and we would want to explore that more, but like not right now. So this will be 2 over 1 plus 6 plus 8, I think, over 15. Got that? All right, this last one is like one where I would actually probably show work and use the rules, even if I were like just doing this on my own. I don't really have a lot more. Oh my God, there's so many more colors. What? I just realized that I could like scroll to the side and get more colors. So I'm gonna make this the 5th root, first ever appearance of this color. The limit as x approaches. You know, it makes sense. There are these 3 little dots, and the whole time I've been doing this, I've been like, I really feel like those do something, but I never knew what, and now I do. They give you more colors. I'm pretty excited about this. All right, so this will be the 5th root. So what I've done is I'm using that property about compositions of functions. I'm bringing the limit inside. I'm going to find the limit, get the value, and then just see if I can evaluate the function, the 5th root at that value. And if I can, I'm good. And if I can't, think of something else. Think of the reason why it doesn't work. But in this case, all right, 3 times 4 is 12, minus 4 is 8. So that's a huge radical sign, but I think that's our answer. All right, let's do this next question. All right, for f of x equals x minus 1 and g of x equals 1 over x minus 1, distinguish between the following limits. All right, so here we go. Let's see what color. Too many now. There's too many options. Oh wait, what? Oh, there's like I can like set my own unique palette of colors. Whew. Options galore. All right, limit as x approaches 1 of f of x. Why would I write this? I'm going to substitute. So f of x is x minus 1. G of x is 1 over x minus 1. All right, this is essentially an order of operations problem. So what I can do here is I can take this and say it's the limit as x approaches 1 of x minus 1 over x minus 1. But we know that that's just 1 as long as x is not equal to 1. But since it's limits, we don't care that we care about x not being 1. We don't care that we should care that x shouldn't be 1 because we're taking a limit. So this is just the limit as x approaches 1 of 1, which is 1. Okay, not a problem, right? Order of operations. First, I do this, then I try to take the limit. That's a rule that you're allowed to follow whenever you run into it. The next problem looks suspiciously like the first, right? So product of the limits is the limit of the product. Limit of product, let me say that right. The limit of a product is the product of the limits, provided that both limits exist. So if the limit is x approaches 1 of f of x and the limit is x approaches 1 of g of x both exist, then I'm allowed to change B, this problem, into problem A. The issue is this will be the limit as x approaches 1 of f of x is x minus 1. That's not a problem, that's just 0. Times the limit as x approaches 1 of 1 over x minus 1. That's actually a big problem. That parentheses there is terrible. That's a big problem, right? So this is 0, but this limit requires more thoughtfulness. So let me think about the graph. So 1 over x minus 1. So it's just 1 over x shifted 1 unit to the right. So at 1, and get a vertical asymptote, and then 1 over x would look like this. It would look better than that, but it would basically look like that. So look at this. The limit as x approaches 1 from the left of 1 over x minus 1 is negative infinity. The limit as x approaches 1 from the right of 1 over x minus 1 is infinity. So this does not exist. So I'm not allowed to combine the two limits because I'm only allowed to combine it into a product if both limits exist, and this one doesn't exist. So what happens here is that the limit overall does not exist. So therefore, the limit as x approaches 1 of f of x times the limit as x approaches 1 of g of x does not exist. Order of operations matters so much on these problems, right? In part A, we got an answer and it was fine because first, it was already a product. If it's already a product, you can algebraically simplify, do your thing, get your answer. In B, it's a product of the limits. So we're supposed to find one limit, find the other limit, and multiply the result. 0 times does not exist. Anything times does not exist doesn't exist. Like, it doesn't exist. I'm going to finish this problem because I think I'm like pretty close. It's not going to take that long, but this video is probably running pretty long, and I apologize for that. But, you know, watch it on a faster setting, or watch it in 3 sittings, or, you know, whatever you want to do. All right, to do this, I need to look at the limit from the left. So the limit as x approaches 0 from the left of f of x is, so this is the work that you should do. Start with the function notation. Now replace it with what you should. All right, if I am to the left, that's a bad minus sign. Okay, if I am to the left of 0, then like -5, -1, negative whatever. Basically, x is less than 0, so I need to use x squared plus 2 cosine of x plus 1 equals, I can do this by substitution. So it's going to be 0 plus 2, the cosine of 0 is 1, 2 plus 1 is 3. All right, limit as x approaches 0 from the right of f of x. So we always start out with the notation, then we switch to the function definition. So if x is greater than 0, then I'm always going to use e to the x minus 4. And e to the x minus 4 is continuous, so the limit is the value of the function. The value of the function, e to the 0 is 1. 1 minus 4 is -3. All right, so we can say, therefore, the limit as x approaches 0 of f of x. Sometimes the iPad just goes crazy. What is this? All right, write it, man. All right, f of x does not exist. And we're done with this page. So that's a good page. A lot of good math there. I'm going to come back in the next video and just keep going. So I hope you're finding this helpful, and I will see you then.